In this video, we're going to explore how to work with dates in MongoDB. We'll cover storing, querying, and manipulating date data types effectively. Whether you're tracking events, scheduling tasks, or analyzing time series data, understanding how to handle dates in MongoDB is crucial. MongoDB offers a couple of ways to store dates. First, there's the bsondate object. This is the native date type in MongoDB, and it stores dates as a 64-bit integer representing the number of milliseconds since the Unix epoch, which is January 1, 1970, at 0 hours, 0 minutes, and 0 seconds UTC. It allows for precise and efficient storage and retrieval of date information. The second is the string format. Dates can be stored as ISO 8601 formatted strings. This format is human-readable and useful for certain applications where readability is important. However, it's generally less efficient for querying and date-based calculations compared to using the native date object. Let's look at some Python examples using pymongo to create date objects. First, to get the current date and time, we import the datetime object from the datetime module. Then we create a variable called current_date and assign it the value of datetime.now, which captures the present moment. To create a specific date, we again use the datetime object and specify the year, month, day, hour, minute, and second. Here, we create a specific date for December 25, 2024, at 14 hours, 30 minutes, and 0 seconds. Finally, to create a date from an ISO formatted string, we can use the datetime from ISO format function, passing in the date string in ISO 8601 format. Now let's see how to store these date objects in MongoDB documents. To insert a document with date fields, we first create a dictionary called document. This dictionary includes a name field set to product launch, a created _ field set to the current date and time using datetime.now, a launch_date field set to December 31, 2024, using datetime, and an updated _ field set to the current UTC time using datetime.now. Then we use the insert_one function on a collection to insert this document into MongoDB. MongoDB provides powerful operators for querying dates. To find documents created after a specific date, we first define a start_date as January 1, 2024. Then we use the find method on a collection with a query that specifies the created _ field should be greater than or equal to the start_date. The $GTE operator stands for greater than or equal to. For a date range query, we define both a start_date and an end_date, in this case January 1, 2024, and December 31, 2024, respectively. We then use the find method with a query that specifies the created _ field should be greater than or equal to the start_date, and less than the end_date. The $LT operator here means less than. Aggregation operations allow you to group and analyze date data in sophisticated ways. Here's how to group documents by year and month. We define a pipeline as a list of aggregation stages. In the first stage, the $group stage, we define an _ID field that specifies how we want to group the documents. We group by year and month, extracting these components from the created _ field using the $year and $month operators, respectively. We also calculate a count field, which represents the number of documents in each group, using the $sum operator set to 1. MongoDB provides a variety of functions for manipulating dates within aggregation pipelines. On the left, we have extraction functions. The $year function extracts the year from a date, $month extracts the month, $day of month extracts the day of the month, $hour extracts the hour, and $day of week extracts the day of the week. On the right, we have calculation functions. The $date add function adds time units to a date, $date subtracts time units, $date diff calculates the difference between two dates, $date to string formats a date as a string, and $date from string parses a string into a date. Here are some best practices and tips for working with dates in MongoDB. First, always store dates in UTC, Coordinated Universal Time, to avoid time zone confusion and ensure consistency across different systems and locations. Second, create indexes on frequently queried date fields to improve query performance. Indexes speed up the retrieval of data. Third, always validate date inputs before storing them in the database to prevent data inconsistencies and errors. Finally, prefer using BSON date objects over strings for storing dates. Date objects offer better query performance and allow you to use MongoDB's date manipulation functions effectively. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.